Welcome and welcome to a new section, MySQL and Docker. Docker should not be a new name to you. There is literally tons of stuff on the internet about Docker. Simply put, Docker is a container orchestration tool. What this really means is like a hypervisor creates a virtual machine, and that virtual machine is isolated from the underlying operating system. A similar way, Docker engine is a hypervisor that runs containers isolated from the underlying operating system. Each container has its own system resources, and the beauty of running containers this way is that less system resources are required. So, almost all the software out there, they are available on Docker, and MySQL is no exception. All these softwares are called Docker images in Docker terms. So Docker Hub is a repository where all these images are hosted. So we will be downloading MySQL image, and then out of this MySQL image, we will create a container which is running form of a MySQL image. Okay, so this is exactly what I just mentioned, that we can run MySQL on Docker. No need to install MySQL packages separately. MySQL will run as a process on a Docker, and MySQL image will be available from the hub.docker.com. We will download MySQL image and then we will run it as a container. And for this, Docker engine is required. Okay, and this is exactly what the next assignment is for Bob. So Bob got this assignment. He needs to install Docker engine. So let's see how Bob does this. Welcome back. So let's install Docker engine before we can pull MySQL image and run it as a container. So I have created this instructional doc in our course GitHub repo, so you and Bob can follow along and perform this exercise. These instructions are for Amazon Linux 2, and Amazon Linux 2 is a Red Hat based system. So I will be using the Yum package manager. So let's go ahead and update our system so all the packages that have updates available can get their latest version. So I will just copy this, paste, then go ahead and search for Docker, copy, so as you can see, we can see that there is a Amazon ECR Docker credential helper, and right there automates the deployment of containerized application Docker for x86-64 systems. Okay, so we did find this one, and let's see what is the version we have. We have 20.10 available. The size for this package is almost 40 megabytes, and it is 86-64 for architecture systems. And we are going to go ahead and let's go. It says install it. So install Docker. Once Docker is installed, it is recommended that whoever the user is running this installation, this user needs to be put in a group called Docker, so it can run different commands. So now if I say, let's see, it says here, if I can run ID is running the user that is logged in. And if that Docker doesn't show up here, let's see, echo user is this user. So let me go ahead, and if Docker is not, it should have actually given this Docker to this user. I can do this way. Let me call this ec2 dash user. Okay, now let's see id or id ec2 dash user Docker right there install. Let me it is actually given this membership to this user. Let me exit out, log back in, and now let's see my id, and I should have a Docker as a extra group. So now once this is done, we need to actually enable the Docker service. We need to start the Docker service, and then we will test it. So right now if I will say Docker version, it will tell me this is the version we have, but it says that cannot connect to the Docker daemon, and because the Docker daemon, the engine, it should have a warren sock file. Remember, in the MySQL side also there is a sock file, the socket file that accept different connections. So it says, is the Docker daemon running? No, it is not running. Let's go ahead then run it. So we first enable Docker to run on a reboot, and then we say that start Docker, and then we are saying if Docker is started, go ahead and give us the status of this. Just like 7 seconds ago, the Docker is running. So now we have confirmed that Docker is running. Let's see if we have any images. Remember, I said every software that we want to run as a container, it is called image, and out of that image is like a cookie cutter. You get a running state of that image is become container. Simple as that. But there's, like I said, that tons of stuff online. You can get any course on Docker. You can get any tutorial on a YouTube or so far. But the thing is, image, container. You just need to remember that. You need to have a Docker engine. You need to pull the image for a software, and you run it, and it will become container. And container is like any other process, but it is totally isolated from the rest of the processes, and it is controlled by control groups and namespace. I don't want to go on that side. So this is out of our topic. What we are doing, we simply want to get a software image. In this case, we are working on MySQL. We want to get MySQL image. We want to run it, and it will run as a container, and we want to manage it. So let's say Docker images. Docker images is the command to check if there are any images I have downloaded on this system. And Docker 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 PS, and I believe Docker container PS is the same command. So Docker PS, like we say PS, like all the running processing on the system. Docker PS mean all the container processes running on this system. So right now we do not have anything. We will stop here. We have successfully installed Docker on our system. Let's go and see that how we can pull a MySQL image, or how we can search and what is available as far as MySQL is concerned. So I will see you in the next lesson. Welcome back. So after Bob has successfully installed Docker engine on the system, he is ready to search for available software images and pull them on his system where Docker engine is running. He will run the command Docker search. Let's say I'm searching for MySQL. So this Docker search image command is linked to a Docker images repository, otherwise called Docker Hub, and it lists all the images from the vendors that are actually having their images on the Docker Hub. So you always want to see name, description, stars, official, and automated. So I'm not giving you any suggestion at that, but I'm just giving you my experience. I always go where it says official is okay. So I don't look anything further down there, even though it could be very useful for my project, but I first prefer to anything that has official image, because I don't know, I have no idea what one particular image will have there, and I don't want to install on my system. So these official images, they have been fully tested, and either they are being managed by the vendor itself or the Docker team itself. So I see these 1, 2, 3, 4 images, they are official, and we can see that one is coming from particular Oracle MySQL, another is MariaDB, another one is PHP admin and Percona. So PHP admin is actually not a MySQL server, so to speak. It is actually an interface where you install and manage MySQL. It gives you a graphical user interface. So, but mainly Percona, MariaDB, MySQL, all these vendors have their software in the form of image also. So let's see, and what is this MySQL? Let's go ahead. Since we have already worked with Percona, now let us work on Oracle MySQL. Okay, so let's copy that. So I will say that let's go ahead and pull this image. So I will say Docker. First you search and then you pull the image. So what this really is doing, that Docker engine installed on this system is looking if this image is already on this system. If it cannot find it, it goes to Docker Hub and it pull by default the latest image. Okay, so this is exactly what it says that, and whenever you see that it says latest, pulling from the library MySQL from the Docker Hub, and then it has these different layers. So these are called layers. So one image is based on, or it is actually created based on layers, one layer on the top of the other. At the end, it check the checksum or it check the digest. If everything is okay, it says downloaded the newer image for MySQL latest. Okay, so we really do not know what this latest mean. We just have now, if I clear the screen, say Docker images now I see that I have a repository, I have an image MySQL, the tag is latest, otherwise it could be 5.7, 8.10, 8.29, and every image has an image ID. When this image was created about 11 days ago, whoever created it, either Oracle or Docker team, and the size of this image is 538 MB. So this MySQL image contains everything in order to have a MySQL, fully fledged MySQL. Okay, so now once we have it, let's go ahead and check that what is the latest version right now under this one. So to check and go inside of any image, we run a command inspect. You can do Docker inspect container, you can do Docker inspect MySQL image or anything. So Docker, actually the option or the command and the object could be image or container or anything else, volume, network, whatever. So Docker inspect this MySQL image that we actually just downloaded. So this gives you all the information about this particular image. It says that where did you get this, what is the ID, what is that the latest? If it is the latest, what is actually the latest? It is actually 8031. Okay, so this is the latest. So this is very, very important to run Docker inspect image command. It tells you that on which host system this image has been downloaded and all other information. You can see that what command should we run when we run this as a container. It says you run MySQL D, and now you know MySQL D is a daemon process for MySQL server. Okay, what is inside this container, this image, what will be the data directory? It will be the var lib MySQL data directory. Okay, what is the entry point? What shell script should run when we run this as a container? Docker entry point .sh, and all other this information on which Docker version this image has been downloaded under .20.10. So this information, where what ports this image when it will run as a container should expose and listen to both 3306, 33060 right there. So all the information is there from where we should find the MySQL utility and other MySQL admin, MySQL binlog. These are the paths should be defined within that container. So all this information is absolutely necessary and must to before you run any image. All these, like what is the storage engines, overlay to versus others, and what are the root file system, all this is all can be get from a Docker course. So since this is not a course on Docker, this is only course on MySQL, so I am giving you only the information that is pertaining to MySQL. So now we have downloaded MySQL image, we have inspected it. Now find a ways how we can run this as a container. So I will see you in the next lesson. Welcome back. So now we have our MySQL image pulled from Docker Hub. We inspected it and found it to be a reliable image, and now we are ready to run it on our system as a container. So every image that is hosted on a Docker Hub also has a helper or a starting guide on the Docker Hub also, that describes how to run this image as a container, and MySQL is no exception. So now let's go to the Docker Hub website and search for MySQL image and get the help how to run this MySQL as a container. So I will go here. Let me go to hub.docker.com. This is the Docker images repository. Let me search for MySQL. You don't need you don't need to sign in for searching the images. So right there I was talking about in the Docker search. Docker search is linked to this hub.docker website. These the first four: PHP admin, Percona, MariaDB, and MySQL. And this is what we are talking about. Over 1 billion downloads for the pull has been happened on this one. Over 1 billion, 100 million plus, and 10 million plus. So let's click on the one we are interested in. This is all the information. What are the tags available? If we always want to go back, we don't want to install latest, we want to go back, we have the ability to pull that particular image. Okay, so this information is these are the supported tags, and then quick reference where this in the GitHub repo where all this information is, where is that Docker file that build this image. For now we are not interested in this one. We already know what is MySQL. We just want to go to how to use this image. So it says that the starting MySQL instance is simple. Okay, if that is simple, let's go ahead and copy this. Okay, so now we are done here for now. Let's go back to our image here. Let's see. Let me first see Docker images. Okay, and let me clear the screen. Docker images and Docker PS to make sure we don't have anything. Let's go ahead and customize this Docker run. Actually, Docker run, in the latest version, Docker says that you want to specifically mention which object you want to run. So I want to run Docker container, so I should better say Docker container run. What should be the name of this container? I want to name this, since this is MySQL and it is the latest version, I normally do like 8 is the major, 31 is the minor. So this is how I can have a 5 7, I can have a 8 13. So you got the point. And then E is the extra variable that goes along when this Docker container will initiate it. And remember, we need a temporary password when we install MySQL. In this case here, we need to provide our own password for root, and let's have our famous default root password. And -D is that it says that go ahead and run this in a detach mode. Okay, either you do a fully with a double dashes, or you simple say single dash detach. What this means that after running the container, you give my terminal session back, you give my bash session, you give my shell back. And then what should be the image, that is the last piece, what should be the image I should use when I am creating this container? And we already have this image. Image is MySQL, and what is the tag? Tag is the latest. Control C, Control V. By the way, if you don't give tag here, by default it will assume you are using the you meant to use latest tag. So let's try if it work. If not, then we see that what's going on. Oh, beautiful. So it spit out the container ID. Every image that has a image ID, every container that we run, it has a container ID, and this container ID is a unique. Maybe we have 100 containers running in this system, so every container will have a different container ID, and they are distinguished by their unique container ID. So whenever we mention any of the container, we mention them either by their name as a human readable, or this is the name, or we can refer them with this container ID. And you don't have to actually copy all the IDs, just a few of the bits that will make this unique ID of the container. That should be enough. So now we have container running, we don't know. So for this we need to run docker container ps. Oh yes, definitely one container is running on our system. Let's go and see what these are. The container ID, like I said, that this is the container ID, and they also actually only pulled these few bits of this. And then from where this container is extracted, it is extracted from MySQL image with the latest version. What was the command when this container was initiated? It was docker entry point ... and then it will have an argument like MySQL D. Okay. When this container was started 57 seconds ago, what is the status? Yes, it is up or it is down. Right now it is up. And what are the ports that's been exposed from this container? 3306, 33060. And what is the name of this container? The container name is this one. So now I want to tell you, so it says that MySQL is running with a 3306 port, but remember, when we say, okay, so container is running, if MySQL is running, I should have something out of this bit, right? Okay, definitely. Why? Because I can say run all the show me all the processing that is running on the system. Okay, let's go ahead, and I want to see if MySQL daemon process is running. Indeed, it is running under parent process ID 1210. Okay, how about, so it seems like this system has MySQL running even though there is no MySQL installed there. That's the beauty of Docker container. Okay, how about if I say sudo netstat? Remember, if MySQL is running, I should see a 3306 port, but I don't see it. Why? So pay attention for a second, because these are the ports. Netstat actually give me all the ports that this host, this server, this operating system is exposing to. But remember, every container is a process within this host. Okay, and every container run its in own host name, in own host. It has its own memory, CPU, ports, everything. So this is an isolated environment within this server, and that is the beauty of this Docker. So now, this is what we still wants to connect to MySQL running on port 3306, but from which address, which host name? For this we need to run a command docker container inspect like we did in our image case. So either you give ID or you give the name of the container. So let me go ahead and give the name of the container, and now it gives us all the information about this particular container that is running on our system. So this is very, very important. This is actually, you consider this a whole MySQL server. This is a whole MySQL server. So it gives you a very information. What was, remember, Docker entry point, I was saying that this is the argument it got. Okay, and then the state is running. Okay, what else information is, everything, when it was started, what image was used, everything is in here. The most particular we want to look is which host or which IP address I can access this MySQL, even though everything is same. Like, consider this as this is a MySQL running on the system, but it is only in the isolated environment. Right there the password, right, and this is the version. Now we need to find out right there. It says that the IP address for this MySQL is 172.17.02. I don't want to go into details, but Docker run its own internal networking, and every container has a unique IP address. This is how we connect. So from within the host itself, if I want to connect to this container, I need to use this, and then we will consider this as this is our MySQL host. It is running, listening on port 3306. It has a MySQL running and everything else. So I don't want to make this lengthier than it has already been. Let's stop here and let's go to the next lesson where we can access this MySQL container. So I will see you in the next lesson. Welcome back. So Bob is making a good progress so far, and I hope you too also. You too. Bob got MySQL installed in the Docker, right? But how Bob can look for MySQL log file, in this case the error log file? As you know, MySQL error log file is very, very important as it records every warning and every error in it. And knowing where the log file is and mining it during the troubleshooting is an absolute skill for every DBA. So luckily, Docker provides Docker logs command to read the log files spitted by containers, in this case MySQL container. So let's take a look, actually have a deep look at these log entries in the log file and see how MySQL was started, what was the version of MySQL, what is the temporary root password. Remember, that's the difference I want to specifically mention. We provided a root password. So let's see how Docker container treated as, and then we will go from there to see how we can log in or what is the current state of the MySQL server. So now I am already in the last session. Let's say Docker container logs, and what is the name of the container we want to see? Docker container PS. We want to see the container logs of either ID or our container. That name is this one. Beautiful. And you can see that when we installed MySQL, exactly the same thing. Exactly looks like this is a MySQL server. In reality, it is running in a virtualized process environment, but it exactly spit it out like it was a MySQL server install. So let's go there. It says that starting process MySQL D. We already know initialization of InnoDB started. All the certificate files has been generated, and then X plugin which actually listen on MySQL X socket 33060. Okay, ready for connections. Look at that. What is the version? It is 8031. Where is the socket file? Socket file is right here. Okay, so first it started a temporary, and then it moves on, and then it says stopping temporary, and then it is going to stop here, and then it is going to start with the actual server. So right there, some warnings. Warning is that the skip host cache is deprecated, and also I'm particularly looking for and interested how it created a root password. What it say? Remember we used to say get the root temporary password, but in this case we have already given. So let's see what was the difference here. Right there, warning, root at the rate of localhost is created with empty password. Please consider switching off the initialize insecure option. So we gave the password and here it thinks that root was created with empty password. So this information is very, very important right there. X plugin ready for, this should be 33060 and the other one should be 3306 right there, 3306. So SOC file is available. We have the version, the MySQL server is ready for the connections. So now let's go to the next lesson, and we already know by the inspect command what is the IP address. Now let's see how we can really log into the server, or in this case the container, and how we can access MySQL. So I'll see you in the next lesson. Welcome back. So we have our MySQL running on a host, in this case a container host, and we are ready to access it and log into the MySQL. So now remember, in order to access MySQL from the network or from outside, we have to have some kind of MySQL client installed, right? And if we don't have client installed, we can always directly SSH to the host where MySQL is running, right? And then we can log in as root, and that will be a root logging on the server itself, or we call this localhost. So let's confirm that we don't have a MySQL client installed, neither MySQL command line utility, nor MySQL graphical user interface like MySQL Workbench. So for now, the only option after this is to log into the database host itself. In this case, it will be a MySQL container host. So let me first pick up from where we left off. Which MySQL? We don't have MySQL. We only have a Docker engine installed here. So now the question is, we don't have a MySQL client. How to get into the database host then? So luckily, Docker provides a command exactly for this purpose, and it is docker container exec command, exec or execute. So it has some options. First option is I want to have an interactive mode with the MySQL container host, and I want to get a terminal. I want to get a shell terminal so that I can type some commands, and followed by the container ID or the container name. In this case, we know we have the container name as MySQL 831, mean it is running MySQL version 8.31. And what shell you want? I want bash shell. Beautiful. Did you see that? So this is actually considered this a MySQL database host. But right there, this is actually container of itself. It has its own file system. It has its own directory structure. It has its own memory, CPU, everything. And in it, MySQL is running. Wow. But then what is the difference? If this is no difference than a regular database host or any operating system host, the difference is this is a condensed. It is the shortest version of a full-blown operating system. It will not have all the commands, utilities that we need in a regular, let's say, Linux system. For example, I want to check if MySQL is running on this system or not. I say, like I just did which MySQL, I am doing which MySQL if MySQL client is installed. It says which command is not found. It means this is an operating system where we don't have many commands. Remember, we check PID of MySQL D. If MySQL D is running, there is no PID of command running. How about if this MySQL is running on this host, it should be listening on port 3306. Okay. So I can say netstat minus NTLP, show me the network port in a listening, actually show me let's say grep or like this any, because it will find netstat is not present there. So how come? Because that is the beauty of Docker running in a Dockerized, containerized environment. You only need files that are required to run a program as a container. Okay, so now that's enough. Let's go ahead and directly, we know if it is a MySQL server, it must have a MySQL client. So let's go ahead and run MySQL -u, like we are connecting to any MySQL server with the root user. -p, okay, we are doing on localhost. Right there it says enter password. It means it must have found this MySQL utility. Let's go ahead and provide the password that we have given. Remember in the log it says root is created with the empty password, but actually we already given at the command line when we were initializing this container. This is the password I gave. Look at this. We are connected to MySQL running on this system, and I can tell you -s, I am connected as a root. This is 8.031 MySQL community server. This is Oracle. It has this socket file. It's been running for 43 minutes. It has these number of queries per second running. These are the open tables, everything. Right now it is using Unix socket because we are connected locally. Wow. Let's see if we can see show databases command. Yes, let's see what is the host name, what is the version of this SQL server. The host name is this. The SQL server version we are running is 8031. So you see that this is no difference than what MySQL should be running on a dedicated host. This is the beauty of Docker. So in cases where we don't have a dedicated server, we just want to test something, we want to run MySQL in a container environment, this is the best option to do that. So now we have seen MySQL is running. We have seen that it is accessible. Now let's see that what our other options are where we can connect this MySQL from outside the network. So I'll see you in the next lesson. Welcome back, and let's pick up from where we left off. So in order for MySQL container to be accessible from outside the container host, it has to expose its ports, in this case the port 3306 where MySQL is running, to the Docker host, because Docker host itself is accessible from outside the network, right? So in order to export or in order to expose container port to the host port, we need to run the docker run command, and there is an option we will learn very soon. So first let's go ahead and learn in this lesson how to stop a running container, how to remove a stopped container, and then we will recreate MySQL container with the option where its MySQL port should be exposed to the port on the Docker host itself. So we are already logged into MySQL host within the container. We are within the container. Let's get out of here. Let's run the command docker container ps. We know that container, MySQL container has been running. Let's go ahead and stop this container, and the command will be docker container stop and then the name of the container or the ID of the container. Okay, let's go ahead and try to stop it. It is going there, and it says that when it spit the name, it means this container has been stopped. Can we confirm that? Yeah, right now $ps command actually shows you all the running containers. But what is the command to see the stopped container then? Well, it is with the flag -a. So right now, sorry, this is a double -a. So right now we can see that this container has been exited since 27 seconds. So these are all the containers that are in a stop state. So now how we can delete or remove this container? For this we need to go and we need to say docker container, maybe help command, and see maybe there is a command available. These are all the commands available to Docker, and one of them is right there, remove one or more containers, RM. Let's go ahead and get a help on RM command, and it says that you can run this command with these options. Like if you want to force removal of a running container, if you want to remove the anonymous volume along with the container, you can do that. So let's go ahead and do force and also go ahead and remove the volume, and then it says that then you give the name of the container. In this case our container name is right there. So control C, control V. So we are saying that docker container remove everything that belong to this container, because we are going to recreate this. Let's run this, and it says that docker container has been removed. Let's verify that with the docker ps, nothing, docker ps -a, nothing. So we have removed the container. Let's come back to the next lesson where we will recreate this container with the option where it should have its port exposed to the at least docker host, and then since docker host will have a port, and then we can access that port from outside the network. So I will see you in the next lesson. Welcome back. So we have MySQL server running as a container in an isolated host that outside world cannot access to it. So in order for this container to give access to MySQL to outside world, it needs to expose itself, not fully exposed, but only expose one of its ports, and that port is, in this case, is MySQL port 3306. Now a container can only expose its stuff to the host where it is running under. So let's see how MySQL container expose its port to the host, and then since that host is accessible to the outside world, we can connect to that MySQL container through that host port. And before we do that, generally speaking, you expose a container port to the similar host port. What I mean by this is that let's say you have a Apache server container and it wants to expose its port 80. Then it should be exposing this port to the host port 80 in order to form a uniform coupling. It's not absolutely must, but it is nice to configure this way. So now we have already dropped, or we have already stopped a container and removed it. Let's see if it is gone. So docker ps, nothing should be running, nothing should be stopped. We still have our MySQL latest image. Let's go ahead and see docker container run, what options we have for publishing or exposing a port. So docker run, let's see help, and there's a plethora of options. Some of them we have already used them, like one of them is detach. We are going to use this one more time, and then if you keep looking there, there's a lot of stuff there. Right there is one of them is publish list, and right there publish a container's port to the host. So what this means is that we will have a list of ports where on the left hand side should be container port that we want to expose from container to the host on the right side, on which port on the host side. Okay, so that's exactly what we need. So everything will be the same like we ran before, but there will be a little modification in the run command, and that will be docker run. We already said that the name of this should be 831, right? This is what we named it, and we same thing, MySQL root password, we have it similar to what we have before, right? And again we said -d, we can use the lengthy option d dash dash detach, and then we want to do this guy, and that will be publish, control C, control V, and we want to give it a list. Let's say container port 3306, and I want to export it to 3306, and then at the end what image we should use for this container, and we already have the image up there. So now let's see if this will work. So far so promising. We have spitting out the container ID. It means that Docker PS should give us something. So right there now it says this option was not there before. Now it is saying that port 3306, it is mapped to 3306, or it is exposed to 3306, or it is published to 3306. This container has been up for 8 seconds for now, and this is the name of the container. So now you tell me, if I run now sudo netstat -ntlp, do you think, this is a question to you, do you think that there should be a port number 3306 should be listening from this host? You guess it right. That is correct. There should be 3306. No, it is not saying it is running a MySQL D, but it is actually showing under, it is the running under a proxy called Docker proxy. What this means is that this port is occupying by a Docker engine with the process called Docker proxy, and under the hood this Docker proxy is actually doing this for MySQL. So now, even though there is no MySQL on this host, I don't even have a MySQL client here. Nothing is here. Nothing is here. This PID MySQL D is actually the PID of container. You got it. So this, if you can see that there is no, the port is there, but there is no virtual client, there is no Warley MySQL, there is no MySQL D daemon. So this actually MySQL D daemon is the daemon of the container itself. Now we have the access to this port. Now we can go outside the world, and we can actually, let's go ahead and actually, because I don't want to make it lengthier than this one. Let's stop here and let's go ahead and create a database by SSH into the Docker host, create a database, and then try to access that MySQL container from outside world, from my own workstation. So I will see you in the next lesson. Welcome back. So let's pick up from right where we left off a minute ago. So now we already exposing a port right there. So now in order to have one user remotely log into this MySQL container, let's go ahead and create that one user. And who else will be that user other than our Bob, the DBA? So let's go ahead and say Docker container. Remember the go inside a Docker host. What is the command? Exec. Let me see. So right there, we want to say exec. We want to do interactively because we want to have interaction. We want to have the terminal given to us, and then we need the container, run a command in a container name, and we want container is MySQL. What is that? MySQL, control C, control V, and we want a bash interaction terminal, right? Okay, let me go ahead. Even clear command is not installed on this container. So let's say MySQL -u root -p. Okay, give our password. We are in, let's say now, select user host from MySQL.user. If you remember, if you recall from one of the previous sections, so there is no user Bob. Let's go and create a user, our DBA user, create user Bob identified by, let's say, give him the same password. Okay, user is created, let's go and grant Bob all DBA privileges on asterisk dot asterisk to Bob, and what is next command? With grant option. Otherwise you can't, root cannot log in remotely, and you want to give Bob, so he can give these grants, these permission to other users. Okay, let's go ahead and flush privileges. Okay, you remember all this stuff, right? So we have created a user Bob, right? Now Bob I can go and say select user host from MySQL.user. Select, if I can spell it, SELECT. What am I doing wrong? Select, not CE. That should do it. Now you can see that Bob can connect from any host in the world to this one, and Bob should have show grants for Bob. Bob should have a permission, all of these, including accessing this MySQL container from remote. So let's see how Bob can connect from our own workstation. I'll see you in a moment. Welcome back, folks. So in the previous lesson, we have created our DBA user Bob in a MySQL container, and then we exposed the MySQL container port 3306 to the host where Docker engine is running. So now, since that host where Docker engine is running, it is actually accessible to the world, to the outside, with the public IP address. So now I am sitting on my old Mac workstation where I have a MySQL client installed, and that should be the older one, 8012, because I am using 10.13 Mac OS. So now I have this MySQL client on my local machine, and I want to connect to the MySQL container where it is running as a container inside a host that I know the IP address. So let's go ahead, and I know the address is, so this is the address. So I'm saying that MySQL host is this public IP address. I want to connect with the user Bob, and I will provide the password on when it will prompt me for that. So let me go ahead and provide the password, and you can see that Bob is connected to a MySQL server. Nowhere here it says that this MySQL that Bob is connected to, it is running on a container or not. So this is the beauty of the Docker running program in a Dockerized environment, that not only save you a space, not only space you a computing resources, you can have as many containers with the different versions of MySQL as you want. So right there, Bob did log in as it is. He logged into any other MySQL server. He can run any commands he wants. Let's say show databases. He can even create a database. Let's create a database called employees. Show databases. So this is the employees database. Okay, right? So this employees actually is created on a container that is running inside a Docker host. Let me get off of here. Okay, let me go inside where that is the database host where Docker is running and MySQL container is running here. So if I created this employees database as Bob, I should see this var lib MySQL in the data directory. I should see a folder called employees. But this is the host. If I say sudo ls -ltr var lib MySQL, there is no var lib MySQL here. If I go to inside the container, this is the one, right? Inside the container, I will say ls -ltr var lib MySQL. This is the data directory. This is, you consider this a mini database host within a host. Okay, and there should be employees right there, right there. So this is what I wanted to show you. This is the magic Docker give you in the form of a container. This container, it is just a process. It acts like its own database host, and we can connect to this container if it exposes this 3306 with the username, with the MySQL account that we have. Then once this is exposed, then we know the IP address of this database host. We came off of from this server, and remotely we were able to connect to this MySQL client, MySQL container, as it is a MySQL database server. So let's stop here and let's see what Bob has for us in the next lesson. Welcome back. So now we have a situation, even though Bob can log in remotely to the MySQL container, but we have a situation where the data is lost if the container is actually removed. So let me show you a demo of this, and then we will better understand what challenge we have ahead of us. So let me log back into as a Bob. I logged in as a Bob. Show databases. We have employee database. Is there any table there? No. Let's go ahead, and Bob is creating a table. Create table. Let's call this staff. I call this SID int. Okay. So show tables. Now Bob has created this table in employees database. Okay. I can log off. I can log back in, and I can go to that exit command again, and I can see var lib MySQL. There should be employees, right? And there should be a staff table. Okay. Now the situation is, let's say we want to we want to stop this container, stop docker container stop, and then the command is MySQL 831, right? So we stop the container, and then we went ahead and we removed it, because we, for some reason, we removed this, and let's say remove with the force volume, right? So now if I say docker ps or docker ps minus a, this is gone, right? Let me go ahead and recreate this container like we did in the previous. This is exactly the same command that we did. We want to expose port. We want to in a detached mode. Exactly. Everything is same, right? We created a container, and now if I log off here, let me go ahead and log back in as Bob. So this is a question for you. I gave the correct password for Bob. Could you tell me that if Bob will be able to log back in successfully? Think about it for a second. I'll pause for a second. No. What is the reason behind this? Okay, let me log back into there. Okay, let me go inside again the execute mode, docker container, exec ls minus ltr var lib MySQL. Do you see employees folder here? No. So this is a very critical key point to understand here, that think of every container as separate database host. So when we removed the database, when we removed this container, it removed everything. It removed all the way this var lib MySQL. When we recreated, when we run this container again, it completely gave us a new container ID. Or think of this, it is a completely new database host. Now it will not have what we had before, because before we deleted, we removed this. Remember, we did this. We removed the container. So every container, the takeaway from here is every container is an isolated environment, an isolated room, an isolated server of its own. So they do not share. If you removed it, the data is gone. So now the challenge is, what if I want to keep that database there? then what is the purpose of using MySQL container if I cannot persist the data? So luckily, we have this what is called volume. Docker provides you another option to attach your local volume, disk-based local volume, to the volume inside container. In this case, we want to bind, we want to attach, like we did containers port with the local host port. The similar way, we want to attach wordlib MySQL of container to a local disk-based volume that will be considered as a persisted volume. So let me see that in the next lesson what this persisted volume mean and how we can configure it and how we can save our MySQL data with MySQL container regardless of if one container is removed or not. Whenever a new container is started, it should not bring its own data directory. It should attach to our data directory. So let's see you in the next lesson. So let's pick up from where we left off a second ago. So let me get out of this container, right? And let me go ahead and destroy this container, and then we will see how we can attach, like we attach this port, how we can attach a local volume. So docker container stop MySQL 831. Okay, go ahead and remove it, rm -fv. It is gone, right? It should gone. Okay, now let's go ahead and let me see if let's go ahead and create a local directory, and we will call this a local volume, and then we will attach it. Let me call this MySQL data or something. Let's call this MySQL data. So now I have this MySQL data with 0 bytes owned by local user on my database host where Docker is running. Okay, so we are on the same page, right? Okay, now I want to say Docker container run. Let me see help. Like I said that out of these options we need to find where we can find to attach. We did last time publish list, and there is one option called volume list. So we want to bind mount a volume, we want to bind local volume with the container volume. So we need option this V. Okay, so now let's go ahead and create this volume, create this container again. Let me clear the screen. So let me go back to the same container that we created, not this one but this one. Okay, let me make it up here. So now like we can see that we have everything here. So now we need to attach a local volume. So we will say, let me first see that what is the path of this. So we need this complete path. So we will simply copy this, and remember we have MySQL dash data. Okay, MySQL dash data. So go ahead and attach a volume. So let's, since it is going to be a lengthy line, let me go ahead and use a short version of it. Okay, dash D, and let's use dash P, the short version of this option. Okay, and make a room. Let's have dash volume, or let's go vol, and we want control V and MySQL dash data. Okay, this is my local bind volume where I want to attach this to. I want to bind this with the containers data directory. I believe now you got the point, right? So now whatever is in wordlib MySQL of container, it should actually show up in my local volume. And since this is a disk-based volume, this should persist even though this is gone, the container is gone. So let's see if everything looks okay. Let's go ahead and try to start this. Beautiful. This is a new container. Now let me show you. If I can say MySQL data, you will be surprised to see that all these containers warlib MySQL, it is now reflected in my MySQL.data directory. How cool is this one? So now if everything is okay, if I will go ahead, let me go and I will say, so now what I need to do is I need to exit out of here, right? Okay, let me go ahead and no, I don't have a Bob, but I do have a root, right? I do have a root. Okay, let me go ahead and provide the password. I logged in. Let me go ahead and say create database employees, use employees, create create table. Let's call this staff again SID, and that should be int. Table is created. Show databases, show tables from employees. We have a staff, right? Okay, let's come out of here. Let's clear this. Let's log back in there. Okay, let's see ls minus ltr MySQL data, and right there is your employees. Now you can see this in, if I say sudo, I can see even staff table there. So now, so this user ID and group is picked up by container, because container has warlib MySQL owned by MySQL. So that actually bound to whatever it found on a local system. So now we know how to bind local disk based volume to this one. So in the next assignment, we will go ahead and we will destroy this container, and then we will create a new container with a new container ID, and then we will see if this data persists or not. So meet me in the next assignment. Okay, so now let's go ahead and clear the screen. Docker ps. Let's go ahead and stop this Docker container. Docker container stop MySQL -831 followed by remove, and you will ask me why I am giving option forcefully remove the volume. So this volume, please remember, this is volume that is inside of this container, any volume that is on the fly. This volume is not that is a bind disk based volume. So let me go ahead and show you actually this. I have removed this. Everything is gone. docker docker ps -a, right? This is gone. So now you tell me I have removed the Docker container along with its volume. Now you tell me my local disk that was attached to that warlib. Do you think there will be any file? Think about it. I would say yes. The reason is that is the beauty of this Docker binding the local volume disk base. Even though that container process is gone, I still have data. Now I can spin up another container and I can attach to the same warlib MySQL. I will ask container, don't create your own warlib MySQL. This is your warlib MySQL. Now let me show you how. So let me say Control R, Docker container run. Right there is a command. Docker container run, exactly the same. Go ahead and expose your port and also bind this volume. Let's see. This is a brand new container ID. Now if I say again, data is still there. Let me log out of here. Let me log back in as a root. Let me give this password. Okay, show databases. I should see employees. I should see show tables, I should see staff table. So this is exactly what we wanted to get out of Docker. So this is the beauty of Docker, that if you want to run MySQL server as a container, you don't have to install MySQL whole server. You only need few dependence libraries, and you need the programs that are required to run MySQL in a Dockerized environment. As long as you can bind your local volume to the container, it does not matter you destroy 1 or 100 containers. Your local bind volume will stay persist. So we saw this in a live demo that Docker container was removed. We recreated a new container, but our Docker local storage was still persistent. So this is, I think, one of the biggest advantage of using MySQL in a container environment. So let's see what we have in the next lesson, and I will see you in the next lesson. Welcome back, folks. So here is an interesting assignment for Bob and you, of course. What if we already have a MySQL instance running and we want to convert it into a MySQL container? Sounds challenging, right? We don't want to always start from scratch, like create a container first and then create database objects. What if we already have a good size of MySQL instance running? So here is a scenario we have. We already have a Docker installed, and actually we already have a MySQL container running. And that MySQL container is already occupying the host port 3306, and it is bind to a local volume MySQL-data to its own data dir var lib MySQL. So I think if we can bind this local MySQL data volume to var lib MySQL of container, why can't we do var lib here, var lib MySQL to this var lib MySQL? So please, before going to the next lesson, stop here for a moment and think about possible resolution so we can help Bob do his assignment. Let me also take a moment to think about it, and I will see you very soon. Welcome back, folks. So we have already installed MySQL server. So now the next step should be we should stop MySQL service and then actually run a container with the var lib MySQL that we have just got installed, and then we will try to see if Bob can log in and see that world database. So let me exit out of here and then sudo system ctl stop MySQL d. Now there should be no MySQL and there should be no netstat -ntlp grep 3306. So 3306 port is available because this will be occupied by container port, and MySQL D is all gone. There is no MySQL var lib MySQL locked by a MySQL user right now. So let's go ahead and docker ps, nothing is there. Let's go ahead and run the MySQL container run command, and you know that if you do not remember, Bob or you can always come to our GitHub page, this MySQL data course repo, and this is the installed Docker file, and we are not actually creating this. We are only interested in the middle one. Let's copy this, come back here, and let's modify it. Remember, we don't need MySQL data now. It should be what we already have, var lib MySQL. And then since this var lib MySQL already have the root password, we don't need that parameter, that option. So Docker, I always try to make clear since it is a container command. So let's run Docker container, and Docker also recommend that using Docker container object or image or whatever system. Docker container run name should be this, detached mode, port should be 3306, and bind volume should be Wordly MySQL. Seems everything okay. Let's give it a shot. Beautiful. That is promising because we have a Docker container ID. Let's see if it is still alive. It is still alive. Let's see one more time. Normally what it happens, the Docker container created and then after few seconds it actually died. So far everything looking solid. It means we should have Docker container running off of data directory of MySQL instance. So let's see now what we need to do. We need to actually log off of here. We need to actually try to log in as Bob from our local workstation. So MySQL -u Bob -p, and this should be -h, the host. This is the host where Docker is running and the MySQL container. So let's see if we are able to log in, and here you go. We have 8031. Select host name, version 8031, and this is the MySQL container host name. How cool is that? Show databases, use world, show tables. All the tables are there. Count star from city. Beautiful. So Bob, with the help of your solution, Bob was able to convert a MySQL, a physical MySQL that is installed on a system, either physical or volume, and we were able to convert it into a container. So now maybe this database is very small in size. It doesn't matter. It could be in terabytes. So as long as we have the procedure in place, we can always convert from MySQL server to MySQL container. So I hope that this assignment gave you some more confidence whenever you are working with MySQL in a containerized environment, and I will see you in the next lesson. And that is it for now, dear students. I know it was short course and we did not actually go into the deep nitty-gritty of Docker, and there is a reason for it. Since I only wanted to show you how we can run MySQL on Docker, that is the reason, that is why I actually wanted to stick around the context of MySQL. But nevertheless, we did talk about Docker in general, how Docker has revolutionized that, it's especially around utilizing the compute resources, where in the beginning we used to run software on a bare bone physical machines and then to virtual machines which resided inside the physical machines but looks like separate machines, and how Docker actually went one step ahead. Now you can run many tiny these virtual machines as a processes and totally isolated from each other, and they are all controlled by their own control groups. We installed Docker on Amazon Linux machine. We searched for official images on a Docker hub, and finally we pulled the MySQL image. Then we created a container out of that MySQL image. We performed different operations on Docker container. We demonstrated how persistent volumes can have permanent changes across containers life. Like even if one container died, we can bring another container that is bind to the existing persistent volume. And then finally we installed MySQL, and we also converted actually MySQL instance into a Docker container. Like we stopped MySQL service and we actually binded the MySQL's data dir to the Docker's data dir, and then how we saw that Docker container came up exactly on top of the MySQL data directory. So now we should expect Bob that not only MySQL, but he can actually pull any image that is available on Docker Hub and create a container out of it. So I'll see you in the next topic.